data structures using C, binary search tree, and traversals. In this lecture, you will learn how to traverse a binary search tree. And these search traversals are pre-order, in-order, and post-order traversals. So let us try to find out. So this is a binary search tree. All these numbers have been inserted. In the previous lecture, we learned how to insert numbers into a binary search tree. This is the root. So we started with 50, therefore. Then 20 was given. Therefore, 20 became the left root of the left tree. Then 10 was given. It became the child of 20. Then 30 was given. Then it became the right child, etc. And 80 was given. Then 80 became the right child of this root, etc. And therefore this is the left subtree, this is the right subtree. This is how we created this binary search tree. Now we want to learn how we are going to traverse this tree. And as I said, there are three different methods of traversal. There is called the pre-order, in-order, and post-order traversal. So let us begin with the, here we are. So you have got pre-order, in-order, and post-order traversal. And these are two more things, inserting numbers, which we have learned. And later we will be doing the searching of numbers in a given binary tree. So let us start with the pre-order traversal. As you see here, there is a binary tree here, and the root is 50, and the algorithm for traversing this binary search tree is root left right. I start with the root, and then what I do is I print that number. So that is the first thing. I go to root, print that number. Then I come to left subtree. Again, the root of the left subtree is 20. I print that number. Then I go to the left again, left subtree, but there is no left, only one node is there. Immediately I print that. So I've come to the end of this left subtree of this. Then I go to the right. There may be a subtree, but in this case there is only one number. I print that. So I have finished my left subtree. I have come to the right subtree. Again, root. I print that root. Then I print the left leaf and the right leaf. So this is how I do the pre-order traversal of my binary search tree, starting from root, then left subtree, then right subtree. And each of these subtree, again I start with root, left, right. So let us take one more example. Again, you have got one more tree here. 50 is the root as in the earlier case, but we have got extra numbers here. Let us try. So root, therefore 50. Then I go to I have to do the traversal of the left subtree before I come to the right subtree. Again, root here 50 is printed. Again I print it. Then I go to the right, only one child is there, therefore I print that. Then I come to the right subtree. Again I print 30, then 25, then 40. So I have finished the left subtree. So root left subtree. Then now I have to print the content of the right subtree. Again 80 is the root I printed. Then I come to the left subtree. 60 is the root I printed. There is no left subtree here. Then therefore right contains only one node. And I come to root is over. Then I come to the right. There is only one node here, leaf node. I printed. So this is how I have traversed this binary search tree using the pre-order traversal. Now we come to the in-order traversal of this binary search tree. Again, there is a binary search tree, and the formula algorithm is left, root, right. I start with the leftmost leaf. So left here, therefore it is 10, I print it. I come to root, I print that root. Then the right subtree 30. Then I print root. Left subtree is over. I print the root. Then I come to the right subtree. Again, the leftmost is 60. I print it. Then I print the root. Then I print the right subtree. So this is how I have traversed this binary search tree using in-order traversal. But observe something here. As you see here, the numbers are in the ascending order. Very important uh, observation. Therefore, when you traverse a binary search tree in the in-order traversal, you get those numbers sorted in the ascending order. Therefore, this is also one of the methods we could use to sort given numbers. I've got a list of numbers. I create a binary search tree and then sort it. It becomes much easier, much faster sorting the numbers, and also much faster to search for the numbers. So please remember that. We'll take one more example. So we've got bigger tree now. So left root right. Leftmost is 10. I print it. Then I come to root. I print it. I come to the right subtree. Leftmost is 25. I print it. I go to root. I print it. And then I go to the right subtree. There is only one number there, 35. Then I print 50 root. I finish the left subtree of this root. Now I come to the right subtree. Again, I go to the leftmost, that is uh, 50 is printed here. Now I come to this. So 60 is printed. Then there is no, then I come to right subtree. Again, go to the leftmost. 65 is printed. Then root here. There is no right subtree. I go to the root. I print that root. I come to the right subtree. There is only one leaf. Therefore, it is printed. So this is the in-order traversal of my binary search tree. With that, we come to the next traversal method, what is called the post-order traversal of my binary search tree. Algorithm is left, right, root, left. So I do the left subtree, then the right subtree, then I print the content of the root. So let us see, left subtree. So leftmost is 10. Then I come to right 30, then I print the content of the root. So I finish the left subtree, then I come to the root. So, oh no, sorry, I come to again the right subtree, I print 60, then left, then root, then root. Then I finish right subtree and the left subtree and the right subtree. Now what is left is to print the content of the root. That is how I print therefore the content of the root. So this has become what is called the post-order traversal. Is very important. We have already done it earlier. Now post-order traversal will help us to convert given infix notation to postfix notation. So for example, we'll take this. I've got the infix notation. I can create a binary tree using infix notation. So 24, 10 minus 5 2 plus 2, so 5 plus 2 and divided by. So this is, you have converted infix notation into binary search tree. Now I do the post order traversal of that. Post order left, right, root, left, then right, then root. I have finished my left subtree. I come to the right subtree. 5 left, then right, then root. Then I have finished the right subtree. I am left with the root. So therefore root is there. As you see, therefore, this is the infix notation. This is the postfix notation of this infix notation got from the post order traversal of the binary search tree. So now we have some questions are there. Let us work them out. Construct a binary search tree with the information given below. 10, 4, 3. Of course, you already binary search trees have been given. You have to identify the correct one. Here is given pre-order traversal is 10, 4, 3. Pre-order traversal, the algorithm is root, left, right, pre-order. I start with root, left, right. Let us see therefore. 10 should be the root. Now in these two cases only 10 is the root. So these two are ruled out. Therefore we have to select out of this 10. So is the root. Then again you have to go to the left subtree. Again as you see there it is 4. It is 4. It is 4. So all right, in both the cases is correct. Then 3. Then again you left should be 3 here. This is 3 here, whereas in this case it is 5. So this is not correct. So I have selected already C as the answer. But we will check again. 10, 4, 3, 5. the root, left, right. I have finished the left. Then again, left is not there because the 11, if you suppose there was some other 10.5, it would have been here. Therefore, 11 and 12. And as you see, it is also in, you do the in order traversal. So left root, so left right root, so sorry, left root right, 3 4 5 10 11 12. Therefore C is the answer for this. Let us take one more example. Construct a binary tree using post order and in order sequences. There are two sequences are given. Since the images are already given, binary trees are given, best thing is to start with the in order traversal, or you can start also with post order traversal. Just check therefore. N should be the leftmost. So in this case, these are two are ruled out. Here N is there, N is there. Because in order is, as you see, left root right. So left, then you come to root, NM. So in both cases it is correct, NM. Now I check the right subtree. Now this POQ will be right subtree. Again, P should be the leftmost, but you see that Q is leftmost. Therefore, this is ruled out. Therefore, it has to be D. D is the correct. Again, we go through in order. N, left, M, and then we come to P, O, Q. And check the post order also. So, post order is left, right root. So, left here. Then again P, right, root and root. So this is therefore D is the correct answer. Construct a binary tree search tree using the post order traversal. So post order traversal is the post order traversal is left right root, left right root. So go to the leftmost, check here. This is correct, this is correct, this is correct, all correct is there. Let's then next one, right. So in both the cases it is right. Okay. Then we come to 7, left root. So left right root, root should be 3. It is correct. In 3 cases it is correct. Then it should be, again we have finished, left right root. This should be left of the right subtree. So left of the, it is correct in these two. Therefore it has to be one of these. Then 7 is there. Then 9 should be the right. So in the case, this is wrong. This is correct. 7, 9, 8, 5. Therefore B is the answer. So this is how you can identify. Already trees are given. You have to identify which is the correct one. Much easier. So pre-order, post-order is there. Again post-order. 5. So left, right, root. Left, right, root, root. So this is therefore the correct answer for this. Thank you.